A sloth, a donkey, and a curious human send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
Hi there, Herman and Corn. We had a very good episode talking about the ARCA deprecation in AI and how Anthropic and Google are managing it differently. It is not such an abstract topic. I think that goes through so much of what we cover on this podcast. It might seem very niche or like a very marginal concern, but it's actually pretty important if you are developing an AI tool. And as you mentioned, it's not just, the problem isn't just having to swap environment variables, it's also that the model is actually changing from entity to entity. And we explained how that can be an issue if the behavior changes and why vendors like Anthropic might be in such a hurry to deprecate older models because it's freeing up hardware for newer models, and there may be legal liability risks as well that they're trying to mitigate. We touched upon something in that episode that I'd really love to get deeper into in this podcast, because it's one area of the AI picture that I've kind of haven't really explored yet, because it sounded to me like a lot of complication. But like Herman mentioned in that episode, I'm also warming to the idea because it does make sense, I think, from an architectural standpoint, decoupling the model from your application. I'm talking about AI gateways or proxies, and using LLM proxies. We mentioned LiteLLM to handle the actual routing from your application to different backends. We talked about OpenRouter. That's a great product that I'm a big fan of, but it's just one way to do this. That's a software as a service subscription. They handle the billing, but you can actually do this yourself. You can operate your own gateway. Another area that we're seeing gateways and proxies and middleware become an important thing in AI engineering is at the MCP level. It's becoming challenging to work with many different MCP tools, and the problem with MCP at the moment, which is very much an area of active development, is that you have to be very selective in the ones you choose because of the context flood if you're not. So because none of us want to have to put together 20 different components for every project, there's been some consolidation of the gateway projects in which we have these sort of all-in-one AI gateways that do MCP aggregation, and they also do that AI routing, the model routing, the LLM routing, I should say. We talk about redundancy a lot in this podcast, and there's actually an argument for this to be made on redundancy grounds, that sometimes we do see model providers like Anthropic, their APIs are unreachable just due to the massive demand at peak times, and decoupling from the backend providers with some routing is one smart way to not have that concern. So Herman and Corn, what are some of the AI gateways we're seeing at the moment? Proxy layers, middleware, if a developer was thinking about using one of these in their own project, whether integrating it as a container in a Docker stack, or even just a dependency in a project. I'd love to know a little bit more about some of the main projects. Over to you two.
Hey everyone! Welcome back to my Weird Prompts. It is February 25th, 2026, and we are diving back into the digital trenches. I am Kuhn, and I am here with my brother, the man who has probably spent more time looking at GitHub documentation this week than looking at the actual sun. Herman, how are the eyes holding up?
Herman Poppleberry here, and you are not wrong, Corn. My retinas are basically vibrating at the frequency of a high refresh rate monitor at this point. Although, to be fair, the documentation for some of these new AI gateway projects is actually quite illuminating in its own right. It is a very exciting time to be an engineer in this space because we are finally moving past the Wild West phase of just hitting API endpoints and moving into the civil engineering phase of building robust, scalable infrastructure.
It really is. And today we have a fantastic prompt from Daniel that is going to let us dive right into the deep end of that technical pool. Daniel is asking about AI gateways, proxies, and middleware. He is specifically interested in projects available for developers to integrate into their own stacks right now, whether that is through Docker containers or as direct dependencies. He wants to talk about LLM routing, model context protocol aggregation, and redundancy.
This is such a timely topic, Daniel. We were just talking about the arc of deprecation in episode 808, discussing how Anthropic and Google handle their model life cycles differently. One of the biggest pain points we identified there was the friction of constantly updating your application code every time a model version changes, a provider goes down, or a new, cheaper model is released. AI gateways are essentially the architectural answer to that problem. They are the Nginx of the AI era.
It is the decoupling of the application logic from the underlying model provider. Instead of your app talking directly to OpenAI or Anthropic or a local Llama instance, it talks to a middle layer that handles the complexity for you. Now, Herman, for someone like Daniel who is looking for specific projects to actually implement in 2026, where do we even start? The landscape has exploded in the last year.
It really has. If we are looking at the heavy hitters in the open source space right now, we have to start with LiteLLM. If you are a developer and you are not at least aware of LiteLLM, you are probably working twice as hard as you need to. It is arguably the most popular project in this category because of its sheer versatility. You can use it as a Python library, which makes it a direct dependency in your project, or you can run it as a standalone proxy server using Docker.
I have seen a lot of people moving toward the proxy server approach recently, especially in larger enterprise setups. Why do you think that is? Is it just about language agnosticism, or is there more to it?
That is a big part of it. If you run the LiteLLM proxy in a Docker container, your application can be written in Go, Rust, JavaScript, or whatever you like. It provides an OpenAI compatible endpoint. So your app thinks it is talking to OpenAI, but LiteLLM is actually translating those requests on the fly to over 100 different LLMs. But the real power, and this addresses Daniel's point about redundancy, is in the load balancing and fallbacks.
Let's talk about that redundancy piece, because that is critical for production apps. How does a gateway like LiteLLM actually handle a scenario where, say, Claude 3.5 Sonnet is suddenly returning 500 errors or hitting a rate limit?
This is where it gets really cool. In your LiteLLM configuration file, usually a simple YAML file, you can define a list of models and priorities. You can set it up so that if your primary model fails, it automatically retries with a secondary model. For example, if GPT-4o is down, it can immediately fail over to Claude 3.5 or Gemini 1.5 Pro. You can even set up cooldown periods, so it doesn't keep hammering a provider that is clearly struggling. It handles all that logic at the infrastructure level, so your application code stays clean. It just gets a successful response back, even if the backend provider had to change mid-request.
That is huge for reliability, but I am curious about the performance side of things. If we are adding a whole extra layer, a proxy in a Docker container, aren't we introducing significant latency? In a world where we are fighting for every millisecond in LLM responses, does that middle layer become a bottleneck?
That is a common concern, but the reality is that the overhead of the proxy itself is usually negligible compared to the actual inference time of the LLM. We are talking about a few milliseconds of processing time versus hundreds or thousands of milliseconds for the model to generate tokens. Projects like LiteLLM are built on top of high-performance frameworks like FastAPI and Starlet, so they handle concurrency very well. In fact, you might actually save time by using a gateway because it can handle things like request queuing and smarter load balancing across multiple API keys or accounts.
That is a good point. If you have 5 different OpenAI API keys to bypass rate limits, the gateway can rotate them for you. You don't have to build that logic into your app. Now, Daniel also mentioned another project type, the all-in-one AI gateways. I have been seeing a lot of buzz around OneAPI. Have you looked into that one much lately?
Yes, OneAPI is another very strong contender, particularly popular in the self-hosted community. It is a Go-based project, which makes it incredibly fast and efficient as a Docker container. What I like about OneAPI is its focus on the management interface. It gives you a very clean dashboard to manage your channels, your tokens, and your usage statistics across dozens of different providers. If you are running a small team or a company and you want to give everyone access to AI without handing out individual API keys, one API is a fantastic way to centralize that. It even has a built-in quota system where you can limit how many credits a specific user or application can spend.
It seems like the difference between LiteLLM and OneAPI is almost a matter of philosophy. LiteLLM feels very developer-centric, very focused on the Python ecosystem and programmatic configuration. OneAPI feels more like a piece of infrastructure you set up and manage via a UI.
That is a fair assessment. Though LiteLLM has been adding more UI features recently, OneAPI was built with that administrative layer as a core priority from day one. There is also a project called Portkey, which has an open source gateway that is very impressive. They focus heavily on what they call the AI gateway, which handles things like request retries, timeouts, and even caching. Caching is another huge piece of this puzzle for developers. If two users ask the exact same question, why pay for the tokens and wait for the latency a second time? The gateway can just serve the cached response.
I think we should dig into that caching aspect a bit more. Is it as simple as a key value store of the prompt and the response? Because with LLMIS, even a one-character difference in the prompt can change everything.
Most of these gateways offer simple exact match caching, but some are starting to look at semantic caching. That is where it gets more complex because you have to run an embedding model to see if the new prompt is semantically similar enough to a previous one to justify using the cache. Usually, for a developer looking for a straightforward Docker setup, a standard exact match cache using Redis is the way to go. LiteLLM and Portkey both support Redis backends for this, which makes it very easy to scale. If you are running an RAG system, retrieval augmented generation, where the prompts are often very similar, caching can save you 30 to 40% on your API bill.
Okay, so we have LiteLLM for the Python-heavy or highly configurable stacks, OneAPI for a more managed infrastructure feel, and Portkey for a focus on observability and caching. But Daniel also asked about something that is really on the bleeding edge right now, MCP aggregation. For those who aren't familiar, MCP is the Model Context Protocol, which Anthropic released to standardize how AI models interact with local and remote data sources and tools. Herman, how are gateways evolving to handle this?
This is where the conversation shifts from just routing prompts to routing capabilities. MCP is a game changer because it allows you to build servers that expose specific tools, like a database search tool or a GitHub integration tool, and any MCP-compatible client can use them. The problem Daniel is pointing out is that as you build more of these MCP servers, your application has to manage all those connections.
Right. If you have 10 different MCP servers for different data sources, one for Slack, one for Postgres, one for Google Drive, you don't want your main application to have to maintain 10 separate persistent connections and figure out which tool belongs to which server.
Precisely. We are seeing the emergence of MCP proxies or aggregators. The goal here is to have a single gateway that sits between your LLM and all your MCP servers. You point your LLM to this one gateway, and the gateway says, I have 50 different tools available across these 12 backend servers. When the LLM calls a tool, the gateway routes that call to the correct server gets the result and passes it back. It is essentially a unified interface for the model's entire tool set.
Are there specific projects Daniel should look at for this right now? I know it is still a rapidly evolving space.
It is very early. There is a project called MCP Proxy that is starting to gain some traction. There are also efforts within the LiteLLM community to add MCP support directly into the gateway. The idea would be that your LiteLLM configuration wouldn't just include model endpoints, but also MCP server endpoints. So, your app would send a request to LiteLLM, and LiteLLM would not only choose the best model, but also attach the relevant tool definitions from your aggregated MCP servers. It makes the agentic workflow much easier to manage.
That sounds like the holy grail of AI architecture. A single point of entry for both the intelligence and the tools that intelligence can use. But doesn't that create a massive security risk? If you have one gateway that has access to your databases, your GitHub, and your cloud infrastructure via MCP, and that gateway is also exposed to an LLM that might be susceptible to prompt injection. That feels like a lot of power in one place.
You are hitting on a vital point, Corn. We actually talked about this in episode 671 when we discussed securing model weights and the overall AI attack surface. When you centralize everything into a gateway, that gateway becomes the most sensitive piece of your infrastructure. It is the keys to the kingdom. If a developer is setting this up in a Docker stack, they need to be incredibly careful about how that gateway is exposed.
So, what are the best practices there? If Daniel is putting this in a Docker Compose file, what should he be thinking about beyond just getting it to work?
First and foremost, the gateway should never be directly exposed to the public internet unless it has a very robust authentication layer. Most of these projects support API key authentication for the gateway itself. You should use that. Secondly, you should use Docker's internal networking to ensure that only your application container can talk to the gateway container. And for the MCP side of things, you want to implement the principle of least privilege. Each MCP server should only have the bare minimum permissions it needs to do its job. Don't give an MCP server full admin access to your database if it only needs to read from one table.
That makes sense. It is the same old security principles, just applied to a new type of traffic. I want to go back to the redundancy piece for a second. Daniel mentioned LLM routing. We talked about failover, but what about smart routing based on the complexity of the task? For example, if a user asks a simple question, I want to route it to a cheap model like Haiku or GPT-4o Mini. If it is a complex coding task, I want it to go to Opus or GPT-4o. Can these gateways handle that automatically?
Yes, and this is where it gets really interesting for cost management. LiteLLM has a feature for this, and there are other projects like Martian that specialize in this kind of model routing. The idea is to have a small, very fast classifier model that looks at the incoming prompt and decides which backend model is best suited to handle it. Some gateways allow you to define rules based on the prompt content or metadata. For instance, if the prompt contains the word code, route to a specific model. Or if the character count is over a certain limit, route to a model with a larger context window.
That is a great way to optimize spend. It's almost like the gateway is acting as a preprocessor. It analyzes the intent before the expensive model even sees it.
And it is not just about cost, it is also about latency. If you can answer 30% of your queries with a model that is 10 times faster and 50 times cheaper, your user experience improves dramatically. The gateway makes this transparent to the user. They just see a fast, accurate response every time.
We have covered a lot of ground here, from LiteLLM and OneAPI to the newer MCP aggregation ideas. Before we go any further, I think we should take a quick breath.
Good idea. I could talk about this for hours, but I know we have more to get through.
Herman? Herman, Bubble A, are you there?
Oh, Mom, I am actually recording the show right now. Can I call you back?
Oh, I am so sorry, sweetheart. I didn't realize. I just wanted to remind you, you have that dentist appointment tomorrow morning at 9. Don't forget, you know how they are about the cancellation fee, and I made some of that vegetable soup you like. I left a container by your door. Just make sure you put it in the fridge right away. Don't let it sit out.
Okay, Mom, thank you. I will check the soup. I have to go now. We are live on air.
Oh, okay. Hello to Corn. You boys have a nice talk about your computers. Bye-bye.
Hi, Dorothy. Thanks for the soup.
Sorry about that, everyone. My mother, she has a sixth sense for calling exactly when I am in the middle of a technical deep dive.
Honestly, it is charming. And she is right about that soup. Her vegetable soup is legendary. But back to the world of AI proxies. Before the interruption, we were talking about smart routing. I want to pivot slightly to the developer experience. If Daniel is looking to integrate these as a dependency versus a container, how should he make that choice? When does it make sense to just import a library versus spinning up a whole new service in a stack?
That is a fundamental architectural question. If you are building a simple Python script or a small self-contained application, using something like the LiteLLM library as a direct dependency is incredibly easy. You just pip install it, and you have instant access to all those providers with a single API format. It keeps your deployment simple and doesn't require you to manage a separate Docker container or worry about network latency between services.
But I assume there are limits to that as the project grows.
Once you move into a microservices architecture, or if you have multiple applications that all need to share the same AI infrastructure, the containerized proxy is the way to go. By running the LiteLLM proxy, or 1AP, as a standalone service in your Docker stack, you centralize your API key management, your rate limiting, and your logs. If you need to update your model routing logic, you do it in one place, and every service in your stack benefits immediately. Plus, as we mentioned, it makes your stack language agnostic. Your front-end team writing in TypeScript and your back-end team writing in Go can both use the exact same AI gateway.
That centralization also seems important for observability. If you have 5 different apps calling AI models, it is a nightmare to track total spend and performance across all of them if they are all making direct calls.
Oh, absolutely. Observability is one of the biggest hidden benefits of using a gateway. Most of these projects integrate directly with tools like Langsmith, Helicone, or even standard Prometheus and Grafana setups. You can get a single dashboard that shows you exactly how many tokens you are using, what your average latency is, and which models are failing most often. For a developer like Daniel, who is working in technology communications and AI automation, that kind of data is gold. It allows you to prove the ROI of your AI initiatives and catch issues before they affect users.
Let's talk about the middleware aspect. Daniel mentioned middleware specifically. In the context of AI, what does that actually look like? Is it just about modifying the prompt on the way in, or is there more to it?
It can be both. AI middleware is often used for things like PII masking, where you automatically scrub personally identifiable information from a prompt before it ever leaves your infrastructure. This is huge for compliance. You can also use middleware for prompt injection detection. There are specialized projects like Lakera Guard or Giscard that act as a security layer, scanning incoming prompts for malicious patterns and blocking them at the gateway.
I've also seen people using middleware for prompt enrichment. For example, automatically hitting a vector database to find relevant context and injecting that into the prompt before it goes to the LLM.
Yes, though that is starting to blur the line into what we call RAG, or retrieval, augmented generation. But doing it at the gateway level is an interesting approach because it means your application doesn't even have to know about the vector database. It just sends a question, and the gateway handles the retrieval and the final prompt construction. It is a very powerful way to simplify application code. You could even have middleware that translates the response into a different language or formats it into a specific JSON schema before it returns to the app.
It sounds like we are moving toward a world where the LLM itself is just one small component of a much larger, more complex AI operating system. The gateway is the kernel that manages the resources and the communication between all the different parts.
That is a very apt way to look at it. We are seeing this shift from chat to do, which we explored in episode 795. When you move to agentic AI, the complexity of managing all those moving parts becomes the primary challenge. A robust gateway isn't just a nice to have anymore, it's a foundational requirement. If your agent needs to call 5 different tools and 3 different models to complete a task, you need a central nervous system to coordinate that.
So, if Daniel is looking to get started this weekend, what is his hello world for an AI gateway?
I would say the easiest path is to pull the LiteLLM Docker image, create a simple configuration file with 1 or 2 of his existing API keys, and point a basic script at the LiteLLM endpoint instead of the OpenAI endpoint. Once he sees that working, he can start playing with the more advanced features like load balancing or adding an MCP server to the mix. It is one of those things where once you set it up, you'll wonder how you ever lived without it.
I think it's also worth mentioning that for someone like Daniel, who is an active open source developer, these projects are great places to contribute. Because the field is moving so fast, there are always new providers to add, new MCP features to implement, and better ways to handle observability.
Definitely. The LiteLLM team in particular is incredibly responsive to the community. They are shipping updates almost daily. It is a great example of the kind of high-velocity open-source development that is driving this whole AI revolution forward. And because it's written in Python, it's very accessible for a lot of developers to jump in and add a new provider or a custom middleware hook.
We have talked a lot about the technical side, but I want to touch on the strategic side for a moment. For a company or a developer, does using a gateway increase or decrease your vendor lock-in? On one hand, you are no longer locked into OpenAI's SDK, but on the other hand, you are now dependent on this gateway project.
That is a classic architectural trade-off. However, in this case, I would argue that the gateway significantly decreases your overall risk. If you are using an open source gateway like LiteLLM or OneAPI, you own that infrastructure. If the project maintainers disappear tomorrow, the code is still there, and it is still compatible with the standard OpenAI API format. You have the freedom to switch backend providers in minutes. That flexibility is worth the small overhead of managing the gateway. You are essentially betting on an open standard rather than a proprietary silo.
It's the difference between being locked into a single proprietary API and being locked into an open source standard that gives you access to everything. I know which one I would choose.
And as we saw with the recent model deprecations we discussed in episode 808, that ability to pivot quickly is becoming a survival skill for AI companies. If a model you rely on is suddenly retired or its behavior changes significantly, having a gateway allows you to test and deploy a replacement without a full application deployment cycle. You can do A/B testing at the gateway level, send 10% of traffic to the new model, and see how it performs before committing.
We should probably also mention the Model Context Protocol again in this context. Because MCP is an open standard, it further reinforces this move away from vendor lock-in. If more providers and tool builders adopt MCP, the gateway becomes the universal connector that makes everything play nice together.
Yes, and that is why I am so excited about the aggregation aspect. Imagine a world where you could just plug in a new data source or a new capability to your gateway, and every AI agent in your organization suddenly knows how to use it. No custom integration code, no complex authentication flow for every single app. Just a unified, secure, and observable interface for intelligence. We are talking about a plug-and-play architecture for AI capabilities.
It really feels like we are building the plumbing for the future. It might not be as flashy as a new model with 1 trillion parameters, but this infrastructure is what is going to make AI actually useful and reliable in the real world. You can't have a skyscraper without a solid foundation and reliable pipes.
Well said, Corn. It is the boring stuff that makes the exciting stuff possible. And for nerds like us, the boring stuff is actually the most exciting part. I mean, who doesn't love a well-configured load balancer?
Guaranteed. Now, before we wrap up, let's give Daniel some concrete takeaways. If he is looking for a container for his Docker stack, LiteLLM or OneAP are his best bets for general LLM routing and redundancy. If he wants to dive into the latest MCP aggregation, he should look at the emerging tools like MCP proxy, or keep a close eye on the LiteLLM MCP integrations. And for observability and caching, Portkey or Helicone are excellent middleware options to consider.
That is a solid roadmap. And Daniel, as you are building this out, we would love to hear how it goes. Your prompts always push us to look at the practical, how do we actually build this side of things, and we really appreciate that. It keeps us grounded in the reality of development.
And to all our listeners, if you are finding these deep dives helpful, please take a moment to leave us a review on Spotify or Apple Podcasts. It really helps the show reach more people who are trying to navigate this crazy AI landscape. We are all learning this together in real time.
It really does make a huge difference. And if you want to search our back catalog for more on these topics, like our episode on the Model Context Protocol or our deep dive into AI security, you can find everything at myweirdprompts.com. We have a full archive there, plus an RSS feed for subscribers.
You can also reach us at show@myweirdprompts.com if you have your own prompts or feedback. We love hearing from the community, even if it's just to tell us what kind of soup you're eating.
And a quick shout out to Suno for our show music. It is amazing what those models can do these days.
It really is. Alright, I think that covers it for today. Herman, go check on that soup before it gets cold. I can practically smell the carrots from here.
On my way, corn. I don't want to hear about it from Mum later. She has a very long memory when it comes to neglected soup.
Thanks for listening to my weird prompts. We will see you in the next one.
Goodbye, everyone. Stay curious.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, my weird prompts, where our thoughts go from slow